All right, welcome to Algebra 2. Today's lesson is 8-3, using properties of logarithms. Is a quick lesson. Today's date is Friday, January 15th, 2021. Our objective today is to do what? Someone with a quiet raised hand. Turn on your cameras. Quiet, go for it.
Use the properties of logarithms.
There it is. Can you use them? Like, first you need to know them, then can you use them? Turn on your cameras, come on. Unless you've private messaged me, which is one of you, there should be 5 more people turning on your cameras. Otherwise you're losing points. So properties of exponents. And these come from, this is the review part, and then I'm going to use this review to tell you about why logarithm properties work. Camera being goofy. Okay, see if you can figure it out, Gunnar. I'd appreciate it. B to the power of m times b to the power of n. You guys know this already. You should be able to tell me. What is it? Quiet raise hand. Andres.
B to the power of m n, or m times n. M plus n.
M plus n, yeah.
Yeah.
So whenever you multiply bases, you add the exponents. Perfect. What happens if I, instead of multiplying the multiplying the bases, I divide the bases? How does that change what I'm going to write over here? It's obviously some b to the power of Jade.
M minus n.
There it is, capital M minus capital N. And why is my computer being so slow? What do I have open? I have Word open. I have okay, it's Chrome. What in Chrome is taking up so much? Oh, it's this. It's my emulator. I think that'll speed it up. Okay. And then if I do a power to the power, this is going to be lowercase b to the power of, I'm still getting weird lag. What's going on? The computer just isn't up to scratch. What power do I have up here? What exponent do I have? What?
M times n.
There it is, capital N, or capital M times capital N. So these 3 rules of exponents will spawn 3 rules of logarithms. And again, if you think of this as the what power function, this kind of makes a little bit more sense. It's still confusing. Understanding these logarithms, I'm still not at a 5 out of 5, even after teaching this lesson for 4 years. I'm not at a 5 out of 5. So if you're at a 5 out of 5, you're either lying or you're smarter than Mr. Snell, which is possible. Like, I'm not the smartest mathematician. I work hard, and that's why I look smart. Let's read this. What power does b need to be raised to in order to get to the power of m times n? That's how you read it, as a what power function. And you can rewrite that as, what power does b need to be raised to get to the mth power? And that power, again, this represents a power because it's asking a question. What power does b need to be raised to get to m? So the answer to this thing, this is equal to a power. If this is a power, when I multiply, I'm going to actually add. I can add the powers. So I'm m plus n. I'm adding powers here. So whenever I have multiplication on the inside, I'm actually adding the powers. I can say this is plus log base b of capital N. Again, the logic here is, if this represents a power and this represents a power, adding the powers, adding these powers right here is the equivalent of multiplying the normal bases. The inside of a logarithm is not a base, or sorry, the inside of the logarithm is not a power. The logarithm itself represents the power. Now this is talking about a power. It's why logarithms are so confusing. Like, are we talking about powers? Are we not talking about powers? Are we talking about the base? When you take the logarithm, you're talking about the power. This is a what power function. And you guys can probably take a guess. This is going to be log base b of capital M, some operation. Getting weird lag. Is it going to write the M for me? Is it going to finish? Watch my hands in the air and it's going to finish. No, it's going to lag out on me. Log base b of m, some operation with log base b of capital N. Guess what operation goes in here when we have normal division? Only 2 people know? Come on. 3 people know? Yeah, Jose.
Is it minus?
It is indeed a minus. And this is the most complicated rule of the day. If I have a power to a power, or sorry, it's a base to a power, how do I say power and a power. Well, I can say log of m is a power. So I can say, I'm going to give some room here. Log base, can't spell, log base b of capital M. This is a power. Do you know what else is a power? This n is a power, and I can multiply a power times a power. This does come from this rule, and this is the hardest one to understand why it works. Really, this n on the inside is already a power. Now that I've made this a power by making it a what power function, I can multiply it. The layman, the thing that I always tell people as our trick to remember is that whenever I have a power inside of a logarithm, this power can come down in front. And I'm getting weird lag, which is why that arrow is way too long. And vice versa. This capital N that is out in front, that can go into the logarithm as a power. Gosh dang, this lag is not good. This would be the power right here. So they're interchangeable. So in Khan Academy, they're going to use words like expand. They don't say condense. I use the word condense, but they don't. So what does it mean to expand? Expand looks like this. This is expanding. Typically speaking, they will give you the expanded form on Khan Academy, and they will say something of the form simplify. So I'll say, this has two words. I think of it as condense, but you can think of it as simplify too. Simplify. Let me do the one that I was saying earlier that no one uses, is condense. Condense. I have to write so slow because of the lag. So typically speaking, you're going to be doing this operation where you go to the right, you're going to simplify. Sorry, go to the left. I don't know if my camera is muted or not, but go to the left. Okay, so now you know your three properties. Let me talk about bases. And you've seen one of these bases already, because our whole point of playing our game yesterday, our power game, and watching that really, really dense video with James Grime on Numberphile explaining about E is right now. The reason I talked about it is for this purpose right here. So log of no base of X really means log base 10 of X. Log base 10 of X. So if there's no base, you always assume that the base is 10. Why is this useful? It tells you how many decimal places there are. So for example, if I had a number like you want to deal with really big numbers, logarithms are useful then. So if you're talking about like the stars and stuff like that. So I'm just going to make up 2, 3, 4, 5, 6, 7, 8. If you take the log of this number, this should tell you about how big it is. For example, let's do, and by default, when you do Spotlight search, it does log base 10. If you want to do log base E, you can, yeah, we'll talk about that in a sec. Log of 2, 3, 4, 5, 6, 7, 8. You get 6. Why? Because if I said this was, if I did this in scientific notation, I'm trying to remember scientific notation. If this was in scientific notation, this would be 2.34567 times 10 to the power of, well, how many decimal places did I move? I moved 1, 2, 3. I'm getting weird lag. Come on, computer, catch up. So I'm at 1, 2, 3, 4, 5, and then 6 would have made to the right spot. So this is times 10 to the power of 5. So it's always off by 1 when I do the Spotlight search. So for example, if I just add another number in here, it'll go up to the power of 7. It'll go up to the number 7. If I do another power or another number, it goes up to 8, 9, 10. So a normal 10 base logarithm just kind of counts how big is this number, how many numbers is it. In fact, I think that's just counting the number of, it should be the number of decimal places. I don't know what happened. 1, 2, 3, 4, 5. It is 6. Okay, times 6. I remember that correct. Yeah, so it is the scientific notation. Whatever number is right there, the log will tell you what that number is. It wasn't off by 1. I felt wrong by saying that, and it was wrong. Anyway. So that's log base 10. It isn't used very often, especially like if you're planning on being in AP calculus, you will not see a logarithm. You will see this thing, you'll see ln, which is the natural logarithm. And when I first say that, you're like, wait a sec. If I'm doing natural logarithm, shouldn't it be NL? Why is it ln? It's Latin, it's backwards. But it just is trying to say natural logarithm. This means log base E of X, which is much, much more natural. E is, as we talked about in the, well, as you guys watched the video on yesterday, E is the natural language of growth. So it is a natural way of talking about how things grow exponentially. And it's much more powerful. It's much more easy to manipulate too, especially at the calculus level. So on Khan Academy, if they do these two things, you now know what they mean. They're really just logarithms with two different bases. And you don't have to rewrite out the base. If they write, what is log, if they, well, I'll show an example one. Notice that these don't have any bases. Well, you don't need to say my answer is log base 10 of whatever. You just say log of whatever. You can abbreviate it too. Let's try example one. And maybe I'll just keep scrolling up so you can see the properties still. I want to rewrite this in the form of log of C, no base. How? You're going to use one of these three properties. This is the easy version of the homework. In the future, I'm going to be using like 3 or 4 properties at the same time. This is just one property at a time. Log of 3 plus log of 5. Let me help people out. You're seeing this right here. You're seeing 2 logarithms added together. I want you to simplify. I want you to get over to this direction. Now there's a hand, 2 hands, 3 hands. We're getting more hands. Good. It's the same hands that have already participated though. And the people that have their cameras off are, I have no idea what's going on. Let's just give it to Charles.
Would it be log 3 times 5?
Yep, exactly. Log of 15. Done. The end. Next problem. Again, when you
So you would
add,
simplify it then as well.
yes, you'll
Okay,
simplify.
cool.
Again, just make sure that everyone can see this. If you're adding the logarithms, that means you're really multiplying the inside. You're multiplying the inputs. 3 times 5 is 15. You don't add the inputs. Okay. Let's try this one. I'm going to use each rule once and you'll see if it can work. All right, example 2, log of 20 minus log of 4. 1 hand, 2 hands, 3 hands. There's some hands. There we go. Let's give it to Jade.
Log, is it base or would it just be log 5?
Log of 5, yep. Log of 5, because again, 20 divided by 4 is 5. A minus sign, if I'm going backwards with my rules of exponents, or if you just memorize the logarithm rule, it just means divide. Perfect. Let's try example 3. And we're done after example 3. Go for it, Wyatt.
Would it be log 81?
Log of 81, there it is. Because this 2 comes up to the exponent. So it's 9 to the power of 2, and 9 to the power of 2 is 81. Done. All right. Let's get a fist of 5 from everyone. How well can you use the properties of logarithms? A 5, a 5, a 5, a 4, a 2.7, a 4, a 4 from Jessica, a 6 from Sergio. He's like very confident. All right, well, let's see how well you do on the homework. Jenny's at a 4. I have not heard from Fern or Gunner.
5.
Right here. Oh yeah, you're at a 5. You're the first one to message me. I'm sorry, I did not message that. You were too early. Good job. 5. And Gunner?
What? Sorry, I was in the back and I just got back.
Right. So fist of 5, how well can you use the properties of logarithms?